Hello. In this video today, we're going to talk about converting velocity versus time graphs to position versus time graphs. More importantly, what can we obtain from a velocity versus time graph that we cannot obtain from a position versus time graph? So the first thing I'm going to do to start this off is I'm going to go ahead and convert from a position versus time graph or an XT graph to a velocity versus time graph. So in order to do this, I have two graphs here. I have an XT graph and a VT graph. Now, I want to do this quantitatively and very accurately. So the first thing I need to do is I need to calculate the slope of this object, or the slope of this object's position versus time graph. So here I have my first section, and it's a positive slope, and it is somewhat of a fast speed. So if I look at this, and I want to calculate, well, it's rise over run. So let's look at what my rise is. I start at 2, and I go up to 4. So my rise is going to be 2. So slope is speed, so velocity equals delta x over delta t. And so my delta x, well, I start at 2 and I go to 4, is going to be 2 meters. And my delta t, well, I start at 0 seconds and I go to 1 second, is going to be 1 second. And so my answer is going to be 2 divided by 1, which is 2 meters per second. So for this first section, or this first leg of my journey, I'm traveling at 2 meters per second. And it's a positive 2 meters per second, so it's going to look something like this. And so it goes from 0 seconds to 1 second. I'm traveling at 2 meters per second. Now this flat portion of my XT graph tells me that my velocity, or my slope, is 0. Now if my slope is 0, then it's just going to be drawn on the 0 line. And it's going to start from 1 second and go to 2 seconds, just like this flat line does up here. It starts at 1 second and goes to 2 seconds. The next portion is I need to figure out what is the slope of this line. Well, I start here at 4, 2, 4, and then I go to 0, 5, or 5, 0. So my rise in this case, well, I'm going down. And I go down from 4 to 0. So in this case, my velocity is going to go down 4, which is negative 4 meters. So negative 4 meters all over my run. I start at 2 and I go to 5. And I'm going in the positive direction, so that's going to be 3 seconds. And so if I do the math here, I'm going to get a negative, because of the negative sign, a negative 1.33. Now I don't really have to do my calculator on this, but it's going to be negative 1.33 meters per second. So how would I draw that? Well, I go down to the negative side of my velocity time graph. And from 2 seconds to 5 seconds, I'm going to put my line horizontally at negative 1.33. So right there's negative 1.5 is right there. And so if I were to draw this, it's going to be somewhere between negative 1 and negative 1.5. And it would look something like this. So there's my VT graph from my XT graph. Now what I want to do is I want to look at this velocity equation and do some rearranging. So if velocity equals delta x divided by delta t, well then I know that delta x is going to be equal to my velocity times my delta t. And that's a very important concept, because it tells me that if I were to take my velocity, which is the vertical aspect or the vertical component of my VT graph, and multiply it by my time period, which is the horizontal portion of my time graph, then I will get the position. So if I look at this, let's move my calculator out of the way. I don't need it right now. So if I look at this first part, let's get a different color here. Well, my velocity is at 2 meters per second. And my time is at 1 meter per second. And if I were to multiply these two things together, well, This makes a rectangle. If I multiply those two together, I get the area of this rectangle. So the area is going to equal my delta x. So my velocity here is 2 meters per second. So delta x is going to be 2 meters per second times my time, which is going to be 1 second. And so my displacement for this first part of the journey is going to be 2 meters. So if I look here, I start at 2 and I go to 4. So that means my displacement was 2 meters. It went from 2 to 4. Good, that holds true. Now the area underneath this flat portion, or 0, is going to be 0. So my displacement here is going to be 0. Now I want to look at the area underneath the portion where I'm going in the negative direction. Well, I start here at 0 and I go to negative 1.33. So this is going to be negative 1.33 meters per second. And over here, I'm going to be going, I go from 2 seconds all the way to 5 seconds. And so I'm left with this rectangle here. When I multiply them together and I take the area of what's inside, well, my delta x is then going to be negative 1.33 meters per second times my time, which in this case is going to be 3 seconds. Now, I will need my calculator on this, so let's go ahead and use it. All right, so here's my calculator. We'll go ahead and put it over here. And I'm going to go ahead and type into it. So it's going to be negative 1.33. And let's make that negative. And it's going to be times 3 seconds. And that's going to equal negative 3.99, or roughly 4. So let's move that back out of the way. And so that's going to be negative 3.99, which is roughly 4 meters. Now, if I look at this, I went from 4 to 0. So that means my displacement was negative 4. What a coincidence. Negative 4 is what I got whenever I found the area under this curve. Now, if I were to look at my total displacement, so my total displacement, delta x total, well, that's going to be the sum of these two. So it's going to be 2 meters plus a negative 4 meters. And that's going to give me negative 2 meters. Well, let's see here. I started at 2 and I finished at 0. So that means I had to go in the negative direction 2 meters, which is exactly what it's showing me. So the key point that we should have gotten from this lecture is that to find the displacement on a VT graph, the displacement on a VT graph equals the area between the line and the t-axis. Now, in this case, we only saw rectangles. And so we know the area of a rectangle is going to be length times width. But later on, we're going to see triangles, where the area of a triangle is going to equal 1/2 the base times the height. We'll see that when we start talking about acceleration. All right, but right now, we're only worrying about rectangles. Okay, so now you got some practice problems to do. Complete those and check your answers and make sure you're doing this correctly.